Alrighty guys, we are starting into chapter 3, which is all on macromolecules. I'm just going to do the first part today because I'm not sure exactly where we'll get to in class, but it will be somewhere very close to this, and these are the notes that you are going to need to do your assignment tomorrow. We're going to do the notes the same way that we did them last time, so anytime you see something written in blue or highlighted in blue, that is something that you will need to write down. Now, I'm not talking about headings because I have all my headings in blue, I believe, but the actual note portion. And I'll kind of go through and tell you, what you should be and should not be writing down. You'll then submit that to me in a Google Doc at the very end, once we are completely done with chapter 3, which probably will not happen until Friday. So Friday is when that assignment will be there, and you will be doing all of chapter 3's notes. So for today, just kind of save those on your computer and we will add to those tomorrow. So I start off talking about this little pufferfish, and you're probably thinking, why would I talk about a pufferfish when I'm talking about macromolecules? And well, he is a protein, which is one of the macromolecules, so that's kind of interesting. Another cool fact about pufferfish is that they are like a delicacy in other countries. And there are chefs that have to be certified to cut pufferfish because you could actually kill somebody by serving them pufferfish. So I don't know if you are adventurous at all, but you could look that up. It's actually really cool how the chefs have to go through cutting everything. They have a toxin inside of them, and the chefs have to very carefully extract that toxin from the fish. Again, if they miscalculate a little bit, well, the person who eats it is probably going to die. I don't believe there is any type of antidote that they could give you that would save you. So these are the safer versions of carbohydrates, your vegetables and your fruits, and they have sugars inside of them. That's why I called them a carbohydrate. It's not just breads, like I said in our vocab. We're also going to be talking about the term organic, and you will see a lot of things labeled as organic at the grocery store. I'm not talking about organic in the sense of how it was created. I'm talking about organic in the sense of what elements that object contains. So when we talk about organic in this class, I'm talking about things that contain carbon. Anything that contains carbon is said to be organic. You contain carbon, so therefore, by definition, you are actually organic. Organic compounds, most of the time, do not contain carbon. So that is the main difference between organic and inorganic. And I believe next year you'll take inorganic chemistry, so you're going to be talking about things that don't necessarily deal with carbon. Carbon atoms have 4 valence electrons. So if you notice, number 1 is written in blue, so that is where you would want your notes on macromolecules to begin. 4 valence electrons. Carbon must form 4 covalent bonds to complete its valence shell. Now, if you want to, you could summarize a little bit, so you don't have to have it word for word. You could say carbon atoms have 4 valence electrons and must have 4 bonds. 4 valence electrons, 4 bonds. That's really all you need to have written down for your notes. And as I'm going through this, definitely pause the video if you need to at any time. Now this is written in black, so you do not need to have this part down in your notes. Like I said, my headings are blue. I'm going to try to change that. I'm sorry, it was a little oversight on my part. So carbon is readily going to bond with itself, and it'll form straight chains, branched chains, and rings, and I showed you an example of that when we did our vocab. Organic molecules will sometimes consist only of carbon and hydrogen, and when that happens, we call them hydrocarbons. We like to give things nicknames in biology, so we took hydrogen, split that word apart, and added it to carbon, called it a hydrocarbon. This is what a straight chain looks like. Again, nothing for you to write here, just observe the structure of it. It is straight. When I talk about straight chains, I'm talking about the orientation of the carbons, not the hydrogens. We are only talking about how carbon looks. Branched, this is whenever you have a straight chain and then Another one is going to come off of the middle carbon. So it is no longer completely straight. It kind of actually form a triangle if you drew lines. Again, just talking about carbons. The last one is a hydrocarbon ring. And if you notice here, you'll see that there are double bonds in between these carbons. That is because we need to have 4 bonds total. So you have 1 bond to this hydrogen, 1 bond to that carbon, and 2 bonds to this one. And that gives them a total of 4 bonds. This is also written in black. You do not need to write this in your notes. Functional groups are groups of atoms that influence the properties of molecules and chemical reactions in which those molecules participate. Wow, that sounds really, really confusing. We're going to talk about functional groups a lot more whenever we talk about proteins, but I'm going to go through a few of them with you now. This is what a hydroxyl group looks like. So it's going to be a carbon, and you're going to have an O and an H attached to it. Hydrogen and oxygen, hydroxyl. This part you do need to write down because it is written in blue. The OH group makes the molecule it is attached to polar. Polar molecules are going to be hydrophilic, which means that they love water. I always say if you're hydrophilic, you want to be filled up with water. This is what a carboxyl group looks like. So you have a carbon double bonded to an oxygen, and it also is attached to a hydroxyl. An amine group, that has nitrogen attached to 2 hydrogens and an R group. Now there is no element R, so if you look at a periodic table, you're not going to find it. That R just stands for any kind of a variable group. So there's many different things we could put where that R is. We could put a carbon in there, we could put an oxygen in there. It just depends on what type of molecule you're trying to make. A phosphate group, get a little bit bigger here. It contains phosphate in the middle. It has a hydroxyl group on one end, another hydroxyl group on the other end, double bonded to an oxygen, single bonded to an oxygen, and we have a variable group. You are not going to need to memorize any of those, so please don't fret. This little section here is in blue. Make sure you write it down. Macromolecules and polymers. They are made up of small pieces, which are called monomers. Polymerization is the process of monomers combining, and whenever they combine, they're going to form a polymer. You can think of this like a brick wall. If you are building a wall, each individual brick is going to be the monomers, and whenever you combine them, whenever you're cementing them all together, you are going through polymerization, and your end piece there, the whole wall, is going to be a polymer. Or it could even be a macromolecule, depending on how big it is. If you are not a fan of brick walls, I'm going to use a Toy Story example for you. I really like Disney. So let's look at these little monkeys here. We're going to say that one individual monkey is a monomer. Did you guys ever play with a barrel of monkeys whenever you were younger? 2 monkeys would be 2 pieces, which is a polymer. And a macromolecule is going to be a huge polymer, so many monkeys. In reality, macromolecules are huge. You would need a lot of monkeys. Do you imagine having a whole monkey curtain? All right, moving on. Large carbon molecules. These molecules are often built up from smaller, simpler molecules. They're repeating units called monomers. Polymers result by chemical bonding that occurs between successive monomers. This is all in black, so you don't need to write any of it down. And large polymers are called macromolecules. I'm not having you write this down because you actually already wrote this in your vocab. This part you do need to write again. 2 reactions we can have. Condensation reactions, where we join monomers. So you have small, simple monomers. They're forming polymers, and water is released as a byproduct. So you are building something up. In hydrolysis reactions, water is used to split polymers into monomers. So you're breaking them down. So in your body, when would you want to go through, a condensation or a hydrolysis reaction? I'll give you a hint here. There is 5 pounds of simulated fat. That is actually what it looks like inside of you. So if you're trying to lose weight, you would want to go through a hydrolysis reaction because you want to break up all those little fat molecules and get rid of them. Chemically, we can go condensation to the right, hydrolysis would go to the left. So if we're looking at condensation, we have two individual monomers. We are going to, if you notice here, there's water in there. We're going to connect these two monomers to make a polymer, and we are going to get rid of the water. Now, if we want to go the other way, we have our polymer right here for hydrolysis. We're going to add water into this reaction. It's going to enter right in the middle because we're breaking that bond in half. So as we break that bond, those two are going to be separated, and the OH is going to attach to one. This H is going to attach to the other one because it already has an O. Don't need to write this part down. Adenosine triphosphate, ATP, is the molecule that our bodies can use for energy. So let's talk about carbohydrates then. Carbohydrates are comprised of carbon along with hydrogen and oxygen in a ratio of 1 to 2 to 1. You want to follow the general formula CnH2nON. So similar as to how it works in a math class, where N is any number. So if I have my number being 6, C, 6, H, that means 2 times 6, which would give me 12. O, that would be 6. I could do it with N being 4 as well. So if N is 4, I would put a 4 down here. H, 2 times 4 would be an 8. O, 4. Monomer of a carbohydrate is called a monosaccharide or a simple sugar. The most common monosaccharides in carbohydrates are glucose, fructose, and galactose. So this is what they look like chemically. And the cool thing about these guys is that they are called isomers. These are molecules with the exact same chemical formula, but the way that the atoms are put together is different. So if you were looking at one of these, you really have to determine, where is this CH2OH at? Are there OHs in all the same places? And if you really pick it apart, you'll notice that it is a little bit different. Ever so slightly, but it is different. A disaccharide results from two bonded monosaccharides. Examples include sucrose, maltose, and lactose. And a polysaccharide is going to result from bonding many monosaccharides, or many disaccharides. Animals are going to store glucose in a polysaccharide called glycogen. Plants are going to store glucose in a polysaccharide called starch, which is slightly branched. Anybody know who this guy is here? He's a big guy on P90X, which you might have heard of. He also does some 10-minute trainer videos, and he says you can lose weight if you do this video for 10 minutes every day, you'll look like he does. I'm here to tell you that that is not actually true. If you did that 10-minute video 10 times, it might be true, but just doing it once a day, it will help you to get a little more toned, but you're going to be burning up a lot of carbohydrates. In order to start burning those fat molecules up, you need to work out for more than 10 minutes, and it needs to be strenuous work, not just lifting up your legs or doing some squats. So don't believe everything you see on TV and in commercials. Alrighty guys, that is the end of our carbohydrate section of our notes. I believe we get into lipids next. Yep, and I'm not going to do lipids today, so you can stop there and I will talk to you tomorrow.